starting the meeting. Anyway, so hello to everybody. We are here for the presentation of Big Data Euro platform. As you know, we are participating in the Big Data Euro project and NH 2020 project funded by the European Union. And as FAO, the FAO is involved in this project, and our role is mostly to engage the community and to understand what type of application can there be for the big data platform that was developed in the project in the area of food and agricultural data. So this webinar is to introduce the big data platform implemented by Big Data Europe to make big data simpler, cheaper and flexible. The platform is conceived as a state-of-art big data technology and is easily deployable on any infrastructure. And so now Dr. Hajira Jabeen, that is a senior researcher at the University of Bonn, and their research interests include mostly semantic web and big data. And she's working now she's involved in a BDE project in the work package lead for the platform development. So she can start with the presentation, maybe Hajira?
Yeah, hello everyone, and thank you Antonella for the introduction. First I would try to share my screen if it's possible. Yes. Can you see my screen?
Yeah.
Right. Sorry. Right, so I'm Hajira, as Antonina has told, and I've been working as a work package lead for Big Data in Europe platform. And this platform, or the BDE Integrator platform, is being developed with keeping a few of the platform goals in light. And one of the most important goals is to keep this platform open source and free to use for everybody. And then we also want to make it very simple to get started with big data tools and applications. So we want to make it as easy as possible, the use of big data technologies and frameworks. At the same time, we want to support a variety of use cases for which we have 7 societal challenges in big data in Europe, but we want to go beyond that, and we want to support numerous tools and applications on this platform. And at the same time, we want to embrace emerging big data technologies. As you all might know, that the big data platform is expanding at a very fast pace every day, and new technologies are coming in every day. So we want to support most of them, and we want to have a scalable and flexible architecture that allows this support. And in order to give this support, we want to make this integration of custom tools as easy and as flexible as possible. So we want to have a modular structure of the platform that where you can plug in your own custom components and make use of them. So when we started working with the Big Data in Europe project, this is the big data platform that you might have seen already. There are too many tools and applications available, and it's really hard to know beforehand what are the requirements for a particular societal challenge are, or what are requirements for a particular company or an organization that want to use the Big Data in Europe platform. So for this reason, tool of choice initially was the Dockers. So at this very moment, our platform looks something like this, where you could install Dockers on your own premises or on cloud, and then you have Docker Swarm as the orchestration tool and Docker as the packaging tool. So what is Docker? Docker is a very lightweight virtualization tool which allows to wrap all the dependencies of an application such that that application runs as intended regardless of the platform, of the source platform in use. So it would be run similar on Windows or Linux or any other operating system. And then Docker Compose is another tool that allows you to create multi-container applications. So here you could see that Docker Compose allows you to have multiple applications contained within one file. So it's essentially a file that allows you to write scripts for multiple Docker applications. So for Dockers, you have a Docker file that includes the script to create Docker, to create one Docker application, or to create one Docker container. And then you can have multiple containers created within a Docker Compose file. And then Docker Swarm, is a resource manager or orchestrator that allows you to create multiple Docker applications running on a cluster of computers. And this cluster of computers could be hardware or machines on premises or on cloud. So while working with this architecture, we realized some of the shortcomings of this existing tools like Docker Swarm or Docker Compose. So one of the motto of Big Data in Europe technical team is to reuse the components as much as possible and to develop our own when some of our requirements are not met. So one of the most important requirements here was that when we try to create a pipeline or stack of multiple running applications, many times it is needed that applications should have dependence on each other. For example, if you want to create a Spark application, it might be needed that Spark application needs to read something from the HDFS. So in this particular case, you need HDFS to be up and running before Spark worker tries to read some data from HDFS. Similarly, Spark master has to be running before Spark workers try to connect to the master. So there is a data flow dependency between multiple applications, which is not possible in Docker Compose, which tries to create all the Dockers at the same time. So in order to overcome this limitation, we created an init daemon support layer, which allows you to create such dependencies for Docker containers. So yet another limitation, I wouldn't call it limitation, but yet another observation was that most of the big data tools, they have their own web interfaces. For example, Spark has its own interface, HDFS has its own interface, then HDFS Manager and HDFS Data Node, they have separate interfaces that you could access on different URLs. So what we did within Big Data in Europe platform is that we have created an integrator UI that allows you to bundle all these different interfaces together into one, and you could access them using different tabs of the same interface, and it also tries to give them same look and feel as if you're running one application. So yet other interfaces are pipeline monitor application, which allows you to monitor the status of the pipeline that you have created, and Swarm user interface that allows you to scale up or scale down the number of instances of a particular Docker image. So this support layer is actually optional. So if a particular user does not want to have dependencies within their pipeline, they don't require that. At the same time, they are maybe competent enough that they don't want to use the user interfaces or they don't want to use the other extra features. You can opt out of using the support layer. So because this support layer itself is a Docker, so if you don't need it, you may not need to pull this Docker image and work with it. And that's the beauty of Docker-based architecture that we have created, that it gives us the modular structure. If you you can make use of only components that you require as a user, and you don't need to install or you don't need to download the whole stack altogether on your premises. In addition to the existing big data tools and applications available, we are also working on semantic big data that I will explain later in my slides. So a more fine-grained view of the platform architecture in big data in Europe looks something like this, that you have a hardware layer where you have machines on premises or on cloud. Then as a resource management layer, we are making use of Docker Swarm. Then you have data layer where you can have multiple data ingestion and data storage tools like Hadoop, any RDF store, NoSQL store, Elasticsearch, and many others. Then there is a platform layer where you could use Spark, Flink, Kafka, or some tools from semantic layer like Sansa or Ontario. Then we have a support layer that supports you to make all these steps, this installation and working with those tools easier. And at the top there is an application layer where you need to write your own algorithms to work with your own data and to create some applications that are required. So the frameworks that we support so far include a wide range of functions. For example, for searching and indexing, some of them are for data acquisition, message passing, data storage, data processing, and semantic components. At the same time, as I mentioned before, that you could create and introduce your custom tools as well. So the life cycle of big data integrator stack looks something like this, that the first step is to deploy a cluster on your premises or to deploy a stack or platform on your premises. After this deployment, you need to monitor this cluster or you need to monitor the application stack. So we have given some monitoring tools. At the same time, you would like to develop some custom applications on top of this big data in your stack. Then a user needs to know how to package their custom Docker images. That could be applications or that could be new tools that they want to introduce into big data in Europe stack. Then composition is how you compose one particular application, which of the frameworks are integrated together. So it's essentially integration. And enhancement is again including custom components or creating a workflow of your custom components, init daemon or use, or how to use integrator user interface for that custom component. So if you take an abstract view of the platform development, there are multiple levels of granularity. At high level, you need to create a Docker compose.yaml file that describes the pipeline topology. And then within that Docker compose file, you could use Big Data in Europe provided components that are already provided on the GitHub, and you can extend the provided templates with your own code. At the same time, you could also introduce new components. That essentially means to build a new Docker image for your component, which, as I said before, the Dockers are your lightweight virtual machines. And you could share these components on GitHub. So this means that there are different types of actors involved in big data in Europe architecture or in the use of this architecture. So one is the DevOps person who would do the cluster setup. The second is the developer that would develop multiple applications, analytics applications for these big data tools. Then packaging, someone who would package these applications so that they are deployed on the cluster. Then integration, that you integrate multiple applications together to create a full working pipeline, and then actually deploying this pipeline on the cluster and monitoring the working of this whole pipeline architecture. Big Data in Europe has made all these steps very easy, and you could, an average computer science or an average technical person is able to perform all these steps within a matter of days, if not hours. we have provided instructions for all of these steps, and it makes it very easy and straightforward to go through all of these steps. So we have provided instructions for platform installation, which are very easy to use. You could find them on GitHub. There are also screencasts on YouTube that you could follow to install the base platform. For development, we have provided multiple templates on the GitHub, so you could easily extend these templates with your own custom algorithms or providing your own data to extend them. And published components can be found on GitHub, automated builds can be found on Docker Hub, and extensive documentation is presented at BDE Wiki on GitHub. Stack is what I called pipeline before. It is a collection of communicating components to solve a specific problem, and this needs to be described in Docker Compose file. So it has to have component configurations, and it describes the application topology. So we are working on creating a user interface to deploy a stack where you could click and select different components necessary to create such an application topology. So in order to enhance the component, if you need to have a workflow within your components, then you need to have an orchestrator that makes sure that that workflow works as intended, that we call init daemon. So it takes care about the component dependencies and any manual intervention if required. And user interfaces make sure that you could see and monitor the components. So there are multiple user interfaces that we have created, as I mentioned before. So the aim of these user interfaces is to facilitate the use of platform and to make it easier to work with big data tools. So these interfaces are workflow user interface includes workflow builder and monitor, and swarm user interface, and an integrator user interface. Workflow builder allows you to pick components from the Big Data in Europe repository and create a workflow out of them. For example, you need HDFS first, Spark the second, and after that you want to populate HDFS with the data. And then you might want to run a Spark application on it. So it helps you to create the workflow, and then workflow monitor allows you to see the status of individual Docker components, if they are ready, or if they are running, or if they've stopped or finished their execution. SORM UI allows you to scale up or scale down the number of Docker images running on a particular cluster, and you can scale up the number of components. For example, if you want to have more Spark workers because you want to increase the computation power, you could do that using the SORM UI. So you could also see their logging using the SORM UI. An integrator UI is what integrates the different web interfaces of particular frameworks all together so that you could see them under one interface combined together. So apart from these advances that we have mentioned before, we also tried to extend beyond the state of the art. And the basic idea is to increase the value of big data by adding meaning to it or semantifying the data. One of the research directions in this particular idea is semantic data lake. So what happens usually is that you have data of multiple different forms, which could be structured, semi-structured, or unstructured. So this data in its total form is schema-less. So the basic idea is that we add a semantic layer on top of these data sets, which are of different form and different granularity. And this data is then semantically lifted by adding meaning to it in terms of, in the form of ontology terms. So this is what we call data lake. This allows you to query this data without knowing the form of data, and then these federated queries figure out what is the actual type of data and to give you the right answers for the queries, which are actually pertaining to different types of data. Yet another research direction is that we are building an out-of-the-box library named SANSAS, that is Scalable Semantics Analytics Stack. So what happens is that RDF is a powerful data integration and data modeling tool. It is very expressive and it is a standardized format. But to date, this RDF data is usually used for querying and getting some fact answering or some Sparkle query answering from the data. On the other hand, analytics are usually done on CSV or tabular form of data. So a lot of effort is being done to manually or to clean the data to present it in a particular form that is usable for the analytics algorithms, for example, support vector machine or neural networks. So we want to combine best of both of worlds. We are creating a library that allows you to perform querying, inferencing, and machine learning on RDF data out of the box. So this SANSA is divided into 4 different layers, where the bottom layer is the knowledge representation layer, and on top of it you have querying layer, where you could query or you could question different facts present in the data. Then inference is knowledge-based enhancement, where based on existing rules you could extend the current knowledge. And machine learning layer is essentially the analytics, where you could perform classification, link prediction, clustering, or many other analytics algorithms on top of RDF data. So that was a summarized version of what Big Data Integrator platform is and how it works. And thank you very much.
Hi, Hajira, and welcome to everybody. That I'm seeing that a lot of people is connecting only now because of technical problems that I don't understand. A lot of people writing me that maybe there was a wrong link, but it's strange because it was always the same link, so I don't know what happened. Anyway, we are really sorry for this, and we will send you as soon as possible the registration of this webinar and the presentation. Anyway, Hajira, can I ask you please to just do a resume of what you said about the Big Data Euro platform, maybe just to talk about the technologies and that Big Data platform includes, and maybe the most important advantage of the platform.
I'm sorry, how I understood it. Do you want me to summarize what I just said?
Yeah, sorry.
Okay.
Because a lot of people just connect now.
Okay. I will just go back to the main architecture slide and try to explain it in a few minutes. Yeah. So Big Data in Europe platform is a flexible, extensible, and modular platform which allows you to create the big data pipeline or big data stack of multiple applications together very easily. So what we have done is there are very nice and easy to install, easy to use tools and user interfaces that anyone can use. And we are particularly making use of Dockers, and Docker Compose snippets are there on Big Data in Europe platform on GitHub, where you can pull them and use them as a template or as an example to create your own pipeline. So what you could do is that you could use this user interface provided by Big Data in Europe to pull multiple components to create your own pipeline. You can add your own components following the guidelines provided by us. So it's flexible. You could use what we have already provided, and you could also add on it. And it's flexible because of the Dockers, and Docker Swarm is what allows you to create such a pipeline on a cluster. It takes care of the resource management, it takes care of the orchestration, and support layer takes care of the workflow between different depending applications within your platform. Yeah, I think this is the overall summary of what I just presented before. So if there are any questions, feel free to ask.
Thank you, Hajira. Is there any question? Just Emmanuel Mondon say that he wants to ask a question about security. Just wait that they are writing.
No, we haven't particularly addressed security explicitly. We depend on Dockers for the security, and Dockers itself has security as one of its important building blocks. So you could say Big Data in your platform is as secure as Dockers are.
Okay. And I saw also someone else that was writing a question. Yeah, Mr. Igini. Just wait. Yeah, he has to share the GitHub page. Thank you, Hajira. So, are there more questions? Someone else that wants to have something?
No, I think. Thank you very much, Antonella, for
thank you, Hajira.
giving
I'm sorry
me
for all the problems.
Thank you.
Problem. So
Okay.
now we can proceed with the presentation of the pilot. The project will also implement pilot application that for each of the 7H 2020 societal challenge. And our technical partner for the food and agriculture challenge has started developing a pilot application for viticulture. And Maritina, Dr. Maritina Stavrakaki, is an agriculturist, and she has a diploma in crop science and engineering, a PhD in viticulture at the University of Athens, and she works with Agroknow, so she can present this pilot. Okay, Maritina, can you start?
Hi everyone. Thanks for being here. I hope that you can hear me.
Yeah.
Give me a moment, please, to share my presentation. Okay, I hope that you can all see my screen. So as Antonella said, FAO and Agroknow are responsible for a societal challenge 2 related to food and agriculture. And I'm going to present you our pilot that we have been developing with the help of FAO and Agroknow as technical partner for our case. As you know, agriculture is one of those domains where data are present throughout the entire research process. And in most cases, if not in all cases, these data are completely and extremely heterogeneous. And what we try to do is take this as a starting point, that research is a data-driven process, and we're dealing with huge volumes of heterogeneous data. What we did as a pilot is we just took viticulture as an instance, and of course our pilot can also be adapted and developed in other crops. And we chose viticulture because grapevine is a product that powers different industries. From agriculture, when we're talking about grapes, it goes to the food industry with wines, and it can even go up to the health sector, for example, with cosmetics or medicines that are based on grapes. And all these different sectors, this grapevine power industry is characterized by a data spectrum which is extremely heterogeneous and subsequently big. And we are talking about satellite data, we're talking about genomic data, sensor data, weather data, of course bibliographic data on researches that have been done on viticulture and agriculture, and of course we're also talking about in-field observations. So all of this data spectrum is completely heterogeneous. And of course, when we're talking about big data and our project Big Data Europe, we're talking about the famous 4 V's of big data: volume, velocity, variety, and veracity. More information on these V's can be found also in our website, bigdataeurope.eu. The point here being that while all these volumes and this fast-moving data of different variety and veracity, they need to be turned into value. If we have data that are not able to understand, or people are not able to manage them, we don't have value. That's why we consider that value is the 5th hidden V, which matters the most. And the idea here is how to turn all this data, all this different and heterogeneous data, into knowledge and value, not only for researchers, but whoever our end users might be, farmers, researchers, simple users without any expertise. And when we discussed about viticulture, we have some sector-specific research questions, research problems, let's say, when it comes to identification of grapevine varieties, when we're talking about viticulture in terms of climate change, and when we are talking also about having the full profile of grapevine varieties. And when we're discussing about grapevine varieties, we're talking about more than 300 of them worldwide. So we have the volume, we have the variety, and we also have the other V's behind the big data of agriculture and viticulture. And all these sector-specific research questions affect all sectors of the grapevine power data value chain. So it is worth mentioning here, of course, that viticulture and winemaking is a cross-border activity, and we're talking about the majority of European countries, as well as new players in this industry, like China, of course. We're reaching up to Australia and New Zealand, and of course America. So it's not something that is just about Greece or Europe, or it's worldwide. The idea here behind the pilot that we have developing is that VITIS is a non-commercial toolkit for viticultural research. It ranges from web-based environments for data management, visualization, and predictive model execution to mobile apps and sensors for in-field data collection. What VITIS does is to exploit core technologies and components of the Big Data Europe platform for solving specific real-world problems of the viticulture research community. And we do that by assessing research results produced through basing and applied research. And we also provide integrated tools for the end users, such as weather forecast and mobile applications for, as I said, for in-field data collection. And what we have done, we began doing this by collecting information on the core 68 grapevine varieties cultivated in Greece. It's just an instance, as I said, so this can be also applied to the other varieties that are being cultivated worldwide. We also emphasize on the discovery and linking of information related to the use and exploitation of viticultural research data. And of course, there is also a large-scale linguistic pipeline by using the components, as I said, of Big Data Europe. At the same time, there is also an atlas of viticultural research created relevant to VITIS grape varieties, information that has been extracted from indexed publications in order to create a first map of researchers. And as I said, the importance and the emphasis was on the linking of heterogeneous data from publicly available APIs and obviously from open source databases. Different data, heterogeneous, different types of information and semantic layer, as Hajira mentioned previously, that has been processed. And we also have, as I said, sensor and weather and satellite imaging, and all these data are linked, are combined, and presented through a very nice, intuitive, and visualized way. Of course, VITIS has also, we have also developed some mobile applications for in-field data collection that can be downloaded, and they work on at the moment on the VITIS app is available at the Google Play Store. And this is a powerful and useful tool which we hope in the next cycle it can be tested with real users, and to see how in-field data collection can be improved and helped through our VITIS application. Of course, there will be other integrated tools for end users. These are more specific, research-specific tools, for example, that matters to viticultural researchers, such as abelographic and genetic identification. And here again, the core components of the BDE platform help in building all these tools, and they need to be, of course, tested and by real users in the next coming months. Of course, there are a lot of technological challenges for this ecosystem, and as the pilot development moves forward, we will have more data to be processed and integrated into the pilot, mainly satellite images and sensor data from by using the principles of precision agriculture. So gradually we are going to integrate all this data into our VITIS pilot. And as I said, VITIS is just an instance. By combining and linking all this heterogeneous data in terms of viticulture, we can also apply these pilots to different crops, and not only, of course, viticulture. Thank you very much for your participation and attention. You can always visit vitis.agroknow.com if you need to find more about the pilot. As I said, it's still in development, but some of the features are fully working. And whatever you want to ask, of course, I'm here to answer your questions. Thank you very much.
Thank you, Maritina. And is there any question? Pietro is typing something. Pietro ask Maritina how people could exploit this data.
Are we talking about normal everyday people or researchers, for example, or more specific to the pilot or to well, obviously, we are using data that are open, coming from the Agricultural University of Athens. These are experimental data. The idea behind this is to see how we can combine different information that is currently scattered across sources. For example, all the data that are now in the pilot are from open databases, of course, and all the information about weather data are from publicly available APIs. The idea is to create a central hub now in the case of viticulture, where people can visit this starting point and have information and access to bibliographic data, bibliographic resources, for example, from Agris or different databases that we have access to, obviously. And how this data can then be exploited, it's mostly on the user. How, for example, if a researcher wants to find information on Greek grapevine varieties, he can then, for example, further his research or compare his results with results from Greece, for example. About professional exploitation, at the moment, of course, VITIS is a non-commercial toolkit. It's not meant to be exploited in a commercial way. However, it's a very good point if someone has advanced knowledge on how weather, for example, and temperature and humidity and all this affect, for example, the physiology of the grapevine. To have information, we have information, for example, on weather data that goes back 10 years, for example. So it's a matter of the user how he wants to exploit data. At this point, it's data that are open, so we provide access to this data that are found, as I said, scattered across different sources. So for the time being, this can be one way to the first exploitation of data, to have access to the data. It is just a pilot, of course, and the feedback by users will be always is more than important to see how we can proceed and make the pilot better.
Okay, thanks, Maritina. Pietro, I think he said something else.
Mm-hmm. Yeah, as I said, agriculture is one of those domains where data begin even in the field. And for example, the process of how to choose and select the correct, let's say, plant sample is of major importance. And in the case of viticulture, it's even more important because when we specify a sample that needs to be collected, we also need to have some geotagging, some pictures taken at different stages of growth of the plant. So the application that we have developed will facilitate in this. It will be a different way of gathering all this infill data. And I don't know if there are any initiatives at the moment. There is just a data collection application, but it will be connected with the VITIS pilot altogether. We're still, as I said, the pilot is still a work in progress. I think by the end of May we will have a more functioning version, and users will be able to actually test the data and download it and have access to pictures. And as I said, one of the major things that are done in viticulture is the ambelographic description using a specific ontology developed by the organization of the World Wine and Vine Organization. And so it will be a new approach of how to actually do the same exercise by using digital means, using the mobile app. So we'll see how that will go in the future.
Okay, thank you, Maritina. Emmanuel Mondon is asking something, I think. Emmanuel asking if you're using Copernicus data and information.
I think that I think if it were not using them already, we're going to use them. As I said, we're going to use whatever is publicly available out there, and we're going to find a way how to very nicely combine all this data. At the moment, I think we're using Sentinel data from Sentinel-2 mission, and I think the images are annotated by with the use of Geoclidean. But if you need more technical information on this, you can also find it in the VITIS webpage, or we can also offer some documentation about the technical aspects from my colleagues at Agroknow. But yes, as you wrote, the Sentinel-2 mission, I think it's is used.
Okay, thank you. Anyway, you can also raise your hand, and then I can just give you the permission to talk if you want to have questions. Okay, Manuel said that he is happy to have more information about, to receive more information about it.
Okay.
Okay. We'll take you updated. Monica Bergman is asking something, and one person, Valeria Pesce, raises her hand. Just wait, Valeria, for Monica, and then I can give you the voice. Monica asks if there is...
You mean to integrate citizen scientists in the pilot? I don't know, at this point... at this point we are just integrated scientists that have been indexed through Agris, for example. When we indexed the open access publications, the scientists, the researchers were also added to the VITIS Atlas. I don't know if there is the thought for integrating citizen scientists, but as I said, VITIS is it's a non-commercial toolkit. During this testing phase, of course, access to the advanced features when it comes to mobile application and will be granted to those that are viticulture-related researchers, at this point at least. But I don't see why not in the future anyone can have access to data. I mean, it is, after all, open data, so no one is excluded. I'm just repeating that for this testing phase, access to full features of the mobile application will be given to those that have something to do with viticulture from the different universities, companies, vineyards, just so we can test the application with real users that know a bit, they have an expertise, let's say, in this field.
Okay, thank you. Monica said also thank you. And Valeria, can you ask now your question?
Yes, thank you. Thank you, Maritina. I have a question for you. I know that you are the viticulture expert, you're not the developer, so you didn't work on the actual integration of the big data technologies, but maybe you have some feedback from the developer who did it. And what was their impression as to the ease of use of the platform. Did they give you any feedback on how easy it was to use the technologies from the big data platform?
I think that Hajira was also a part of the team that was working with Agroknow. At least that's my impression. At least in the early beginning of the pilot development. I don't know if Hajira has some input on this, but from what at least I know, as you said, I'm not a technical expert. I think they had no problem integrating components with the BDE platform and using the components offered by the BDE platform. But if Hajira has something more to add on this, please be my guest.
Yeah, thank you. Yeah, I have the same opinion because I also worked on this SE2 as well for the for the PDF file processing, and yes, it's how it worked was that platform was being developed in parallel to the development of each of the societal challenge pipeline. So now we are at the stage where we are integrating both efforts together, that to run the pipeline on Big Data in Europe platform. And we have at least 3 of these pipelines fully working with the platform at the moment, and the developers who did it, they found it easy to use, and I think we have heard nice comments about this integration.
Thank you very much.
Emmanuel Mondon is typing something. Just wait for another question. He said that to know that Euclidean is part of the industry alliance across Europe and is a coordinator.
Okay.
Emmanuel, do you want to raise your hand, and maybe you can easily talk? Maybe it's better to explain what you want to say. Now you can talk. Manuel?
Hello, do you hear me?
Yes, yes, we can hear you.
Yeah, okay, thanks.
Hi.
Yeah, so I'm deeply involved in the geospatial domain, focusing on Earth observation, and that's why I was asking you if you are using Copernicus data and information. And I'm coordinating an industry alliance across Europe, gathering 50 partners, developing and operating information as a service derived from geospatial resources. So you mentioned Euclidean. Is it the company I was referring to, or another one?
Yes, this is the one.
Great. Okay. Yes. And then you
sorry to interrupt you. Yes, please.
Yeah, so just to mention, through this alliance, we are able to support various use cases, providing information as a service, dealing with Earth observation, such as accessing Sentinel-1, Sentinel-2, and even Copernicus core services, discovering it through SATCAT service, for instance, provided by EPROC, viewing it through WMS, WCS, and even processing it across multi-cloud. So if you're interested in, let me know and I can send you additional details.
Thank you. Yes. I just copied the about section just so that anyone can see from what are the data sources, what are the where do these images come from, satellite images, weather data, so it's all there. If anyone wants to have any more insight on what has been already used. But thank you very much for this. I already took a note because I'm not the one collecting these data. But sure, why not? This is very nice. Thank you.
My pleasure.
Okay, thank you, Maritina. Thank you, Emmanuel. Is there any further question? It seems no, maybe. I would just have to Pietro, because I saw before and maybe I missed sorry Pietro, I missed your question. You was telling that maybe the slide misses the balance. I want to ask you, what do you mean with the balance? Are you there, Pietro? Yes, he's writing. Yes, he said that just another balance is the correlation between data on the slide listing the 5V were listed only 4V. Maritina. Maritina say thank you for pointing out. Okay, okay. So there was just, I think, a mistake. Thank you. Any other question? No, maybe. Okay, so maybe we can close this webinar. Thank you all, thank you everybody for coming, for participating, and sorry again for the technical problems. We will send you the recorded webinar, the link to the recorded webinar, and if you have any further requests, just write in me. Just you can write me, and okay. Thank you. Bye bye. Have a nice day.
Bye bye, everybody.
Thank you and bye.